Hi friends, um, my name is Joy. Today I'm going to give you a presentation on technology framework. Now, the intention of this presentation or the intention of this session is to go through some of the core concepts of technology landscape. Most important thing that we have to understand is what are the latest technology stack that the industry is dealing with. What is the market standard? What does the market need, right? And the most important part about accepting and adapting a technology is, why do we need the technology? What is the demand for the technology? There are many, we have seen in course of years that technology landscape has changed drastically from one form to another form. There was times when people used to build applications which will work only with the desktops, simple apps, simple applications that can run in a desktops, in a standalone system, as a matter of fact. And with course of time, the technology landscape has evolved in such a way that it can adapt the latest code base, the latest type of technology, which can be implemented to solve different set of problems, which are much more meaningful, and that is helping to understand the real-time scenarios. From desktop applications, we move to web applications, where we are hosting websites, we were building web applications, we're building websites, we're hosting them, we're using them. All the major industries have been using those websites in order to interact with the data, get the information, store it somewhere in some kind of a database, like SQL Server, MySQL, and many other different types of databases. And then eventually from websites, we moved into mobile applications, where it's you are dealing with the data on your fingertips. Now with mobile applications, now it is coming to a point where you are basically trying to use the devices that is available and make those devices connect to each other, right? So it's now more it's more challenging as we move away from one specific sphere of technology to another sphere of technology. With this evolution of technology landscape, you will see that there are the demands of the skilled people who can learn the technology, adapt it, implement it, and make use of this technology to deal with the data. And of course, one of the major reason of evolution of a technology landscape is data, right? Because at one point of time, if you think about 10 years back, for us, data was simply few information. Like for example, you go to you book a airline, right? So all you need is the customer info. So you get the customer information, you get from which city to which city the customer is trying to book the flight, what is the primary information of the customer, and the customer has booked the flight, checked out, and then it just goes to the payment page and he just paid it. But the next point that comes into picture is, can the customer book the flight instead of going to a web application or a website? Can he book the flight from a mobile app, right? So a native mobile app been introduced, which is we are building in order to help the customer to use the mobile device in order to interact with the application and book the flights. And eventually then it came with more evolution where the customer is interacting with the application through different types of platforms. Different intelligent systems has been built, right? So evolution of technology or the landscape change of a technology is entirely depends on the analysis of the data, the understanding of what exactly the market needs and what is the current requirement of the market. What do we see in our day-to-day changes? What are the problem statement that we are looking into in our day-to-day lives? And then, taking more and more in-depth portion of that particular problem statement and finding a solution, a better solution towards it. So the technology landscape has changed drastically over times, and it's going to change more. AI, artificial intelligence, is bringing a lot of platforms. It's bringing a lot of focus towards the evolution of data and the evolution of human interpretation of the logical thinking to more machine language instructions. So this is something that we need to understand, that what are the different technologies stack that the world is looking into, where is the world leading to, right? Once we get a kind of an understanding of it, then it's pretty much it's quite it's pretty much permissible to know that yes, this is what we have to think about, this is what we need to adapt. So I'm going to go ahead with a kind of a glance over the technology stack, which is, this session is not intended to go to the depth, because if you have to go to the depth, you have to go to each of this technology stack and understand how this technology is working, why it is introduced, what are the benefits, what are the pros, what are the cons. But I'm not going to that level at this moment, because that cannot be done within one session. You need to go through each bit of technologies more in depth. So this is going to be a very small session, which is just going to touch base the technology, give you a kind of an idea that this is what the technology is. This is what the IT industry needs. This is what the market demands. This is what each of the industry, maybe hospital, medical services, hospital services, or it can be insurance, it can be airline, it can be travel industry, it can be food industry, it can be automobile industry, any kind of industry. They need the technology to adapt their requirement, to take their requirement, convert into their business case studies, and actually build the solution which can solve the problems. So these are the technology landscape that we are going to deal with. So let me go ahead with one of the first, the first slide, which is going to give you list of technologies that we know is growing right now, and it's in high demand in the market. So these are the list of technology that you can see in the first slide: the cloud, machine learning, DevOps, data science, quantum computing, AR, VR, automation, cybersecurity, drone technology, blockchain, Internet of Things, modernization, and microservices. I would say that these are kind of like the high level. These are the platforms. These are the technology landscape. These are the technology set, which is kind of mastering most of the problem statement that the world is facing these days. And these technology skills is very demanding these days for the industry to adapt they're moving more from their legacy applications, which was built way like 10-15 years back, and they're trying to adapt this technology landscape to make their application or the solution more robust, more performance oriented, more goal oriented, to solve the problems and find a perfect, reliable solution, right? Okay, so let's start with cloud. What's cloud? What is a cloud, right? Okay, so think about a situation, right? It's not a situation, basically. This is what we have been seeing all these years, that every industry, every company, every implementations have their on-premise physical bare metal systems, right? So for example, if you have your company website, you have built a company website and you want to host your applications, you want to host your websites, you want to host your data, right? You want to have a database server and everything, right? So you need a web server, you need a database server, you need the monitoring system tools. So everything that you are doing is on premise, right? You're buying the resources, you are deploying those resources on premise, and you are using them. Now these resources are 24/7 available for sure, but there are a lot of ifs and buts. There are a lot of pros and cons. Obviously the pros is that these resources are manageable by you, and it's not exposed to the outside world, unless and until you authorize the outside entity to to use the resources. But the con side over here is the maintenance of the resources, right? The maintenance of your servers, the managing those resources. And the most important part that I would always like to highlight over here, that some of the time the resources are in idle state, right? Because you're not using that. The traffic is very less. What I mean by traffic is the internet, the consumers, right? Who are trying to hook into your applications or visiting your website. Most of the time what happens is you might find that out of 1,000 users who are actually visiting your website every day, maybe there is a day when you get 0 users. But the thing is, your server is still running 24/7. You cannot shut down the server. You cannot shut down your applications, because you don't know when the user is going to come. So there are a lot of challenges involved. You need a good IT department who will be managing those servers, who will be maintaining the servers, who will be upgrading the softwares, the hardwares of the servers, because this is also very important. As time goes by, the expiry date of the softwares are always there. Some of the softwares get expired, and the support system for those softwares are not available. So you have to keep a checkpoint. You have to keep a track of those kind of softwares, like the operating systems, or some kind of application softwares that has been almost like that's no more use anymore, right? So it's the support for those softwares, for those operating systems has been expired. None of the provider is not supporting. So you have to keep a track of that, and you have to upgrade your systems, upgrade your softwares. You have to keep an IT department to actually handle the situation, right? Then the cost. Today you have say 1,000 users visiting your website, which is hosted in a web server, almost like a day, right? For example, tomorrow you are getting like, out of 1,000, you are getting like 10,000 users who are visiting your website in a day. So the traffic is increased. And when the traffic is increased, your application server, which was built to handle like 1,000 users, so max to max like the 2,000 users, that server is not able to manage or is not able to handle this so many requests, like 10,000 requests coming in fraction of a seconds. So your application crashes, right? Your softwares, your hardwares are giving performance issues, right? There are performance counters that you'll find for all operating systems, and the performance issues are coming up, right? You will find your system is getting crashed, your machines are getting crashed. You have to shut down, you have to reboot the systems, you have to reconfigure the system. So there are a lot of issues that happens. So the scaling of the machines, the scaling of the systems, you have to take a chance over there. You have to track those the problem statements, and then you have to scale the system accordingly based on the situation that you are going to see. What about a provider, someone who comes to you and say, hey, you don't need to do anything about it. You don't need to worry about upgrading your systems, upgrading your softwares, or keeping a checkpoint about your traffic. You don't need to worry about all those things. Give me the responsibility. I'm responsible to do that. All you need to do is you build your applications, you give it to me, and I'm going to take care about your softwares, your hardwares, right? So it's kind of like you get a helping hand, right? And what that particular provider is saying that, all you have to do is just pay me as per use. What I mean by pay per use is that, if you have 1,000 users who is visiting your website, you pay for the 1,000 requests. If you have 500 requests a day, the next day you got only 500 requests, you pay only for those 500 requests. You don't pay for 1,000 requests, right? You don't need to pay for the server, for running a server for 24/7. You still have an option to have your own server, which will run 24/7, but I give you the facility where you don't need to run a server 24/7. It's on demand. Whenever there is a request coming, whenever there is some kind of the pool happening for the data, the application is spinning up. The application, the server is running, right? Otherwise, the server is in idle state. It goes to an idle state. So that's what the cloud is. Cloud, actually what it is doing is giving you services which is over their data centers. And the data centers contains all the available providers, available services, the features that can be used in order to interact with the data, interact with the application that you are giving to them, you are hosting there, and it is using that, right? Another example of how the cloud is useful is, for example, for some reason, right, your network goes down. So when the network is down, your servers are down, right? So when the server is down, obviously the customers will not be able to access your web applications. Now the cloud is giving you the flexibility of managing that kind of failover scenarios, right? So they have regions or zones, you can say, where they have multiple, the multiple data centers will have these particular machines which is reallocated. And what happens if one of the data center is down for some of the reasons like network issues or some kind of disasters that happens, you have the another data center that is running and your customers is getting redirected to that data center, which is kind of like available at this point. So there are a lot of terminologies over here called availability zones and other stuff. So, but each of the cloud providers has their own set of terminologies. So that's where the cloud is. Cloud gives you everything that you need, and you don't need to manage the softwares, the hardwares by yourself. It has three things. It has three components. One is called infrastructure as a service, another is called platform as a service, another is called the software as a service. Now, infrastructure as a service is where you are in the virtual machine that you have on your on-premise. The same virtual machine is in the cloud, right? So you have your infrastructure in cloud. So that's called infrastructure as a service. The platform as a service is where your application is managed and the infrastructure is also managed by the cloud. Okay. Basically, like, for example, SQL Server is a platform as a service. Okay. So you have the SQL Server, which is a PaaS, right? It's the managed SQL Server instance. Okay. It's a database server, which is managed by the cloud. And as well as the hardware components is also managed by the cloud. And then you have software as a service, where the softwares, the platform, and the infrastructure is managed by the cloud. For example, Office 365. The whole Office 365 is managed by the cloud. It is giving you a software, it is giving a platform, it is giving the infrastructure as well. Everything is managed by the cloud. So these are the three different components that cloud has. And eventually, if you see, there are three major cloud providers: Azure, the Microsoft, Amazon, AWS, and Google. And they are using the same terminologies. The same concepts applies for their cloud platforms, the services and the resources. The only thing that you might see is there is a difference between the naming conventions that are used to identify their resources or the services. Okay, so this is all about cloud. The second technology is the machine learning, ML, which is a subset of artificial intelligence. Artificial intelligence is a superset, right? Now, we all know what AI is. We all know what is the capability of an AI is, right? At one point of time, AI was kind of a dream project for most of the technology specialists. They used to think like, I would learn AI and build the robots, and I would learn to build how a robot interact with the real time, data, or the real world. Now that stage has been gone. Now you can be a part of the AI revolution by yourself, because right now the market, the demand, the industry needs is to make more and more intelligent platforms and services and systems that can identify a particular problem statement, can solve it automatically, and give a resolution in just a fraction of a second. So basically, to come to a conclusion that AI is already integrated as part of our implementations that is there in our day-to-day lives. The only thing is the approach that we are dealing with the AI is in a different way. Okay. Machine learning is a subset of AI. Now, what is machine learning is, the simple terms, with the name itself, it's pretty much clear that the machine is trying to learn the capabilities, or you are using some kind of algorithms or some kind of a logical, conclusion or logical reasoning to the machines. You are making the machine to understand a logic and drive a solution based on that particular logic. Okay, so that is what machine learning does. It takes the algorithms, it takes some kind of a logical reasoning steps, which is interpreted in machine learning languages, and that can be used to identify a real world problem statement and drive a solution out of it. Basically, it is integrated to the AI again. Okay. The third technology skills is DevOps. Okay, so now DevOps has played a vital role in course of 10, 12 years down the line. The reason I would say it has played a very vital role is nowadays the industry is demanding engineers who have hands-on experience with DevOps, just like the industry is dealing with engineers who have hands-on experience with cloud technology. One of the important aspects that you will try to look into is the attrition rate has increased drastically because of the technology adaptation that the industry is going into. All right. The old languages, the softwares, the old languages, or the old technical skills are no more valid to handle the situations, the current market requirement or industry needs. So it's very important for people to enhance their skill set to get acknowledged with that adaptation and and be accepted by the industry. Okay, so DevOps is high in demand, and there was a point where now let me come to a point where the DevOps comes, right? How the DevOps is evolving. Okay, so 10 years back, if you look into the industry, most of the IT companies, what is the structure of an IT company? Let's not go to the different levels of the structure and hierarchy and all. Let's talk about the development team itself, right? So you have a development team who is basically taking a requirement, writing piece of code, and deploying it. Now, the development team is not actually deploying it. They're shipping that piece of code to a particular deployment team, or rather you would say as an operation team. The operation team is responsible to maintain that particular piece of code, take that particular piece of code, deploy it based on the instructions that the development team is providing them, right? Because every piece of code that has been deployed has a different level of instructions, right? So the development team is basically giving the instructions saying that, hey, you have to install these prerequisites in order to let this application or website run in your server. So the deployment team is very much dependable to the development team to get that particular information before even he deploys deploy the code base to the servers, right, to the environment. Now, the problem over here is the dependency is very much over there, right? The development team is dependent on the deployment of the operation team to get the code and deploy it. The operation team is dependent on the development team to get the instructions that is required in order to deploy that piece of code. And then another major point over here is the development team doesn't know how the deployment is happening. So what happens is when there is a production issues, right? For example, the website is not running properly. There is a bug in the website, or there is a performance issue with the application, right? It's taking huge amount of time to load. So now the development team is highly dependent on the operation team to give them the feedback or just give them the data points after analyzing what is the bottleneck. Now the look into the deployment team. He doesn't know about the code, right? He's not aware of what language has been used for building the piece of code and deploying it. So now he is also very much dependent on the development team to understand what exactly is going on. And there is always like, you have done this, for you this is a problem. So there is always kind of pinpointing and tug of war between the teams that is happening. DevOps is a methodology. It's a process that brings together all these issues into one single place, bring the set of tools to a team who can handle every end-to-end cycle of the software development. Okay, that what I mean by software development, if you think about a software development life cycle, it starts with the a requirement gathering, then business case studies creation, then development of the code, right? And then testing the piece of code, deploying it to the production servers, and going for user acceptance testing, and then it is going live, right? So this whole end-to-end cycle where your code is coming from a business requirement and it is finally going to the production, that whole thing can be managed by multiple tools. And now the teams, they are not dependent on anyone. So the IT, so there is no development team who is dependent on an operation team. Still, there are a lot of companies and projects who are dealing with that fighting mode, as a matter of fact. But knowing what DevOps does, the fruit, the capability of the DevOps, this particular companies or the project teams, they are moving from these processes, the existing processes, and adapting to the DevOps. Okay, so there are a lot of tools that can be used to provide an end-to-end, and one developer can actually use those tools in order to write a piece of code, do the business requirement, deploy it to the production server, even host the production server, and manage it, monitor it, do everything end-to-end. Now, as a coder, since I'm deploying in my code to the production server, if there is any performance issues, I know the bottleneck of that issue, right? I know where the issue is. I can go back to the code and I can say, hey, I think this is the problem with the code. So I fix it and I redeploy it, right? So that's where the DevOps comes into picture. Data science. What we are talking about as of now, everything is directly or indirectly is related to data, right? Data is everything. Data is everywhere, right? When you come out of your home, when you wake up, right? Everything that you see, everything that you do can be interpreted as a data, right? And that data is used in order to find the problem statement and derive a solution to it. Data science give you the capability to actually analyze that data, train that data accordingly so that it can be understood by machines, by devices, and give the data in the format that can be utilized to solve that particular problem statement. So data science, I would say the data scientists are those who are typically good in statistics, mathematics, because you have a huge amount of algorithms, a lot of calculations, a lot of statistical interpretations, mathematical equations that are required in order to analyze that piece of data. So as a matter of fact, data scientists, the industry needs data scientists who are very good in statistics and mathematics. Most probably, some of the industry even look into PhD of people, who have PhD in mathematics or statistics to be the data scientist. So that's where the data science comes into picture. But along with that, there are a lot of tools that have been introduced in order to deal with the data, to transform the data, to analyze the data, to refactor the data maybe, or filter the data, extract the data, right? So that's where the data science comes. Quantum computing, it's brand new. Again, I would say it's brand new. It's not, it has just entered the market. There is a long way it's going to go. Now, quantum computing has been evolved since, I believe, like 1-2 years back, and they the reason of quantum computing being in this technology landscape is because as we live with the data, as we try to analyze the data, the most important problem statement that comes is there are different sort of data that cannot be easily analyzed by a single piece of algorithm or a piece of software. You need high-end computing systems, very high, which can actually understand the data, which can go to the depth of the data, look into the behavior of the data, find the trace of the data, the history of the data, extract the information out of that trace, out of that thing, and then give you an output that can be utilized to build intelligent systems. So quantum computing is coming up as a kind of a platform which goes to the depth where a simple algorithm or simple logical reasoning cannot go. Okay. AR, VR, we all know, augmented reality and virtual reality, right? So augmented reality is something, now AR, VR has been evolved, right, over time. There was times when we used to play video games, right, computer games, now the virtual appliances, the virtual world is very much important in reality. Okay, so let me give you an example, right? If you look into some of the weather channels like weather.com or Fox Weathers or something like that, there are a lot of weather channels. If you look into that recently, they're using the AR capabilities, which is the augmented reality capability, to actually virtualize an environment that looks like some tornado is happening or cyclone is happening or something like that. The reason it is you can actually stand over there and you can actually show that, hey, here is the water level that is happening, here are some of the some of the devastations that is happening. This is the temperature of this state. This is the highest, the lowest temperature. There's a low belt, there's a high belt. So you can actually show it to the user. You can actually visualize the whole thing and stream it to the user. That's where the augmented reality comes into picture. You don't need to be in the actual reality spot to do that stuff. Basically, you can virtualize the whole environment itself and program it in such a way that it can stream the images that needs to be that is pretty much predictable and that is pretty much related to the real-time events, and you can actually show it over there. So that's where augmented reality comes. Similarly, the virtual reality is where you have the different kind of devices that can be used in order to interact with the virtual world. Okay, so games is one part of the virtual reality. The next technology landscape, the skill, is automation. Everything needs to be automated. The industry is in demand of this particular technology skill because automation is something that needs to be done. The human intervention to the machines are creating chaos, and there are a lot of issues, bugs, and defects that is coming up with human interventions. Of course, it's logical, right? But with automating those particular processes or automating those particular implementation, what is happening is the less the human intervention is, more optimized the implementations are, the more optimized the process is, right? More corrective decisions are being taken for the processes to run. So that's where the automation is coming here. Automate everything. Okay, starting from deployment to process to business case studies, automate. Okay, cybersecurity is another very important aspect, because when you look into the today's world, almost 100% of our interacting of our interaction with the internet is where we are processing our data, right? You are either buying the stuffs through internet, you are sharing your personal images and profiles in internet, you are interacting with people through internet, you are dealing with different kind of facilities through internet. Your data is getting processed, and that's why it's very much important to safeguard your data, safeguard your information, safeguard the things that is required, safeguard the processes, safeguard the infrastructure that is dealing with your data. Cybersecurity is exactly the core of all this information savior. All right, so that's where the cybersecurity plays a vital role, and the industry is moving towards building more and more tools and processes which can secure your data, secure your informations. Drone technology. Drones were already there. We have been seeing drones that has been used in order to capture images, right? If you see some of the vloggers, when they travel, they use drones in order to cover the areas where the drone is running, and it streams the images, streams the videos to the live to the users. But now the drone technology is now evolving from not only from that aspect but into multiple purpose or multiple aspects too. The drone technology is used in order to identify the different kind of data points, like security of a nation. For example, it goes and checks out where the terrorists are, right? Where the militants are. It can be used in order to it can be used in criminal investigations purposes also, like a crime that has been committed, say 6-7 years back in a particular area. The drone technology can be used in order to actually get snap of that particular area. Analyze the data. Obviously the data analysis is not happening in the drone, but it is taking that data, the pixels, the pixels, the picture, the images has been transferred to a service who is basically analyzing that particular data. Or it can be used even to circle a particular pond in order to find the kind of the water contamination which is over there. So drone technology is evolving. There is another part called 3D painting with 3D printing, which is not provided in this particular technology landscape, but 3D printing is immensely used. Recently, I was looking into one of the article where the 3D printing is used to create organic eggs or meat, which is basically created without even killing an animal. Just look into the beauty of it, right? 3D printing can be used in order to build houses, right? Look into the beauty of it. So 3D printing is another technology landscape, technology skills that is coming up. Obviously, not all the countries have evolved with 3D printing, but the things are going on, right? Blockchain, another technology skills which has recently came to the market not very long ago, and we are still trying to adapt and understand how the blockchain works. You have already know about bitcoins, cryptocurrency, and so many stuff, but blockchain is not only bitcoins and cryptocurrency. Blockchain deals with huge piece of information, and each data is kept in a small packet, and each of these packets, right, are chained and they interact with each other. Okay, so blockchain is playing a vital role in insurance, in hospital industry, in automation industry, in payment industries, many areas. So blockchain is a big concept. IoT, Internet of Things, it's one of my favorite, where basically what it does, what do you mean by Internet of Things? Things, if you think about, this bottle, right? Okay, so I want to have some kind of a program which can tell me if the water level is like, in the middle of this bottle, I should get a kind of a notification in my mobile which says that, hey, your water level is 50%. Okay, you need to fill your bottle with water, or the water is empty in this bottle, right? Or dried up. So this is the thing, and the data that I'm capturing from here, passing it to my mobile, right? That's where it's kind of like you are implementing that kind of an interface, or some kind of a device interpretation that can actually interact with this particular thing, and utilize this particular data and analyze it and do the respective calculation that's required. So that's where Internet of Things comes. IoT is also useful in automation, in drone technology, in AR, VR, in machine learning, and many other areas. Modernization and microservices. Now, simple term, we understand what modernization is. Legacy applications that has been built 10, 15 years back, which is prehistoric and cannot be maintainable, need to be moved out of these legacy architecture to more modernized architecture that can be more performance oriented, more optimizable, and more resourceful. That's why modernization concept comes. When the modernization concept comes, a microservices architecture comes into picture, where you have set of small services that are created in order to handle the business case studies. Each of these business cases are basically you are building services around it. It's a wrapper around it. Okay, so that's where the microservices comes into picture. Now there are various tools, there are various language that are used in order to build those microservices, but they all follow some kind of an architectural patterns and practices. And it's very important that a candidate, a person who is working in IT should be aware of microservice architecture, because that's where the industry is going into. Now, if you look into this technology landscape overall, all these technology, cloud, the high demanding right now, if you look into the Indian market or US or the outside market, right? Cloud, machine learning, DevOps, automation, IoT, cybersecurity, microservices and modernizations are the important skills and technologies assets that are used and in high demand by the industry. Drone technology, quantum computing, AR, VR, they are also very important, but they are coming up. They are still in that phase where the adaptation is happening. But you don't need AR, VR in a, what would I say? Like you don't need AR, VR in a patient management system, right? So for if you want to build a patient management system, you don't need an AR, VR. You need a microservices architecture. You need DevOps in order to define the processes. You need machine learning in order to identify the patients, extract the data. For extracting data, you might need data science. You need a cloud environment where you are going to host the applications. You need automation in order to automate the processes that is required for the patient management, right? So some of the stuffs are, some of these technology skill sets are very much important, but some are dependent on the industry that they are related to. Like AR, VR is very much important for, say, automobile industry, right? So like that, right? Okay. So next, I think I have covered almost all the technology landscape skills. The next slides that you are going to see is going to go through just few of those, just going to go through these technology landscape. Whatever I have covered is already there. So I'm not going to repeat them, but I'm going to just go over those slides so that you kind of get a feeling of what they are and what are the different tools, because those are the things that I have covered over there. So let's start with the leaders. We know the primary leaders are Microsoft, Google, and Amazon Web Services. So these are the three major leaders who are working as a primary leaders for technologies. And then there are secondary players for that. You have cloud computing. So I have already explained that. Cloud computing, what a cloud computing is. So cloud computing is the on-demand availability and delivery of computing resources and services, including servers, storage, databases, networking software and analytics and intelligence over the internet, managed by a cloud service provider. So that's what I have explained, what application is, what its platform is, how we are dealing with the cloud computing, why the cloud computing is very much important, what are the different components of cloud computing, right? IaaS, PaaS, and SaaS, that's one of the aspects that I've also shared with you, that infrastructure as a service is where you are moving your bare metal system from your on-premise to the cloud, right? The virtual servers, the network, the storages. PaaS is where you have the software tools and the hardwares available for your application in the cloud. And SaaS is basically the whole software itself, along with the platform, the hardwares, and everything is provided by the cloud. So Azure has many services, platform, infrastructure, and many other services in terms of the cloud. So you can see this particular slide gives you kind of an idea about what are the services that are used in Azure for the cloud computing. platform services, infrastructure services. There are a lot of areas to cover, like the security and management, the compute. Compute is basically which is dealing with different kind of resources that are used to host your applications. Then you have the web and mobile, how you're hosting your web applications and mobile applications. That's also a platform service. Developer services are provided by Azure, which are used by the development team in order to develop for the development purposes, for writing piece of code, sharing the piece of code, or monitoring the application health. Analytics and IoT is used for different kind of data analysis, Internet of Things, and different kind of implementations like machine learning. Data is the area which is dealing with different kind of database servers, database systems, and data services. Along with, we have the integration and media, and there are hybrid operations also. The infrastructure services is basically using compute, storage, and networking. Storage is a bit different with the data, because data is basically data services. Storage is which is basically used in order to store bytes of data in bytes of data. I would not say bytes of data. It is used to store the physical files or images or anything that in forms of a bytes. Okay, and it is stored over there, and you can retrieve it at any point of time. There are 24 regions, 19 online data center infrastructure. This is one, just giving you one snapshot. Similarly, it goes for AWS. As I have already told, all the cloud providers, especially Microsoft, Amazon, and Google, the concept-wise, everything is same. Behind the scene, the concepts are same in terms of compute, in terms of application services, in terms of mobile services, in terms of security, in terms of infrastructure, in terms of data. The concepts are same. The difference is the features, in terms of naming conventions, in terms of some of the features here and there that they have included or excluded. So this is an AWS environment, which is platform, which is using different services for different kind of requirement. Okay. The next one is a Google platform. The same, it is also using different services for the compute, for storage, for networking, for big data. All right, so these are the services. I have explained you about machine learning and artificial intelligence, so I'm not going to go to the depth, but one of the things that we have to understand is the machine learning is also used in order to what the machine learning does is it gets the data, right? It cleans, it extracts the data, it transforms the data, it tests the data, and then it improves the implementation of the data. So there are various processes that is involved in machine learning. So any machine learning tool or algorithm or program that we are using to deal with the data, it's actually going through set of processes. That's what the machine learning does. Machine learning algorithm, machine learning program is being integrated to the AI environment, where it is basically using that particular program in order to intelligently handle those particular data or coming up with the problem solving capabilities. Okay. So Azure gives a tool called Azure Studio Azure ML, which is a machine learning ML studio in Azure. So this is one of the snapshot of what the machine learning studio is and what are the different components of the machine learning studio is, which is provided by Azure. DevOps. I've explained to you what DevOps is. It's a union of development and operation team together into one single umbrella, and you basically use different tool sets in order to improvise your processes and make your development effort more robust, right? both development and deployment effort more robust. And also it's very important, communication, right? You need perfect communication tool which can be used to synchronize the data information, synchronize the development, synchronize all the efforts that is being done. So DevOps gives you a whole set of tools in order to make that process more seamless. Industry is going towards that direction. So there's a high demand of resources in the industry who have experience in DevOps, cloud services, cloud computing. It might be Azure, it might be AWS. As a matter of fact, Google, more than Google, most of the industry they are moving towards Azure, and some of them are moving toward AWS also. But Azure, AWS are playing a vital role. Google is also playing a vital role. So a person who is experienced in the cloud domain and the cloud platform, they are highly in demand with the industry, along with the DevOps. Again, I just want to highlight this because many IT companies right now are trying to adopt DevOps. They're building their own set of frameworks in order to do that. And the frameworks basically deal with different type of tools that is available through DevOps. Okay, so this is, you can see this is a list of tools which are used in as a part of DevOps. I'm not going to the depth again because we don't have that much amount of time. This is but you can actually look into this particular slide and see that you have different level of different types of DevOps tools that can be used in order to streamline your process delivery. Data science is a subset of AI again, which is a scientific way of dealing with the data. It's a scientific method to understand how the data looks like, understand the behavior of the data, the pattern of the data, and how the data works in a timely fashion. So that's where the data science comes into picture. Data science is very much important, and it's used these days extensively to build the ML programs. So they are much more important, like ML. There are different tools in data science, and there are various processes in data science. These are the set of processes. You can look into that. Visualization, statistical modeling, computing, the data technology, doing the research of the data, consulting with the data, dealing with real world problem statements or the applications, scientific methods are different parts or components of the data science. And the tools that we use, like the platform, the frameworks, the languages are there. So basically a data scientist is someone who is good in statistics and mathematics, plus he has experience working with any of the language like Python. Python is widely used in the industry. A person having a good knowledge in Python is kind of like easily consumable by the IT industry. They need those kind of people. Should have experience with like some of the frameworks like TensorFlow, or the tools like Tableau, Jupyter, platform like Spark. It's all you can say. Quantum computing, I have already explained that. It's a sophistical, high-end, powerful machine that is used to deal with more minute level and to the depth of the data and give the output which is much more reliable and ready to be which synchronize with the real world problem statement, give you a solution to it. So it's coming up. It has not been introduced to most of the IT market as of now, but some of the IT giants are trying to use quantum computing into different areas. So it's growing, but not at this stage at this moment. Azure also gives you a platform for quantum computing. It's called Azure Quantum. There's a language called Q#, which is used for that. AR, VR, I have already explained you what is the difference between AR and what is the difference between VR, and they are widely used by the industry these days. You can say 3D printing is also a part. Automation, again, it's very important to automate everything. Automate the processes, automate the implementation, automate the deployment, automate. So it's everywhere. So there are different types of automation. Basically, you have integrated automation, you have industrial automation, you have computer aided manufacturing, RPA, which is robotic process automation, cognitive intelligence, and conversational automations. Now, all these automations, they have their own set of responsibilities that they deal with. For example, let's look into if you look into the RPA, it's basically used to automate the processes, right? Back office operation, for example. So it's used to process the back office operation. For example, let's say the claiming of insurance, or underwriter workflow, or managing the different approval levels. So those can be actually automated through RPA, right? Cognitive intelligence is another aspect that is using that can be used by the programs which is provided by some of the IT giants like Microsoft, Azure, and AWS and all, which can precisely predict the data, and which can give you the information from a particular complicated process. Okay, so that is very highly intensive and intuitive way of dealing with the data. It is trying to exchange the information between an external service or external provider to the machine. The way it is doing is using the conversational automation also. Cognitive is like, it can be used for, like, for example, when you look into a particular data, you visualize it and you interpret that particular data. So that's kind of cognitive thing that is happening. It's reducing the operation cost. But when you look into the conversational automation, it's highly it's using Lewis, the language integrated platforms, which is kind of interacting with the customer through devices. For example, like if you look into the mobile apps, sometimes you get a pop-up saying, there is a Reva or some kind of an auto chatbot who is basically trying to communicate with you. It is asking you the question, you are giving the answers, and then it is trying to find out the best possible answer, or the line of question that it need to ask you, and then it is asking you. So that's kind of conversation that is happening between the system and the human. You have integrated automation, industrial automation, and CAM, right? CAM is used by machines and mostly by industrialists or architects, I would say. Okay, so these are some of the automation tools of RPA. There are ERP, BPM, front office, core RPA capabilities. One of the tools that I have used is called UiPath. It's pretty much very useful in order to automate the whole processes and workflows. Cybersecurity, I have explained you. So there is nothing more over here. So it's one of the very important area that is trying to be that the world is trying to emphasize on, because as we are moving towards the usage of data, there is a huge amount of data breach or data security breach that is happening all around the world in all platforms. It's very important to secure your data, secure information, encrypt it, so that it cannot be hacked. or phishing, like phishing, hacking, malwares, viruses, worms. These are the various ways, the cybersecurity, the cyber criminals are trying to extract the vital part of the information from the data. Drone technology, which I have already explained. This is one of a case study of the drone where you are using a flight controller program, which is sending the data in Azure IoT gateway, and that information that it is capturing, it is then processed, and we are using the stream analytics to analyze this particular data and then interpret it data to the Power BI, which is business intelligence tool for visualization. So you can see different steps, right? You have a drone which is sending the data to a processing and managing messaging system, which is again connecting to the devices using device connection IoT hub. It is then processing data, it is storing it, then visualizing, interpreting the data in a visualized format. Blockchain, as I have already mentioned, small blocks of information which is much secured and in a cryptographic format, and they have a huge amount of data, and they are all chained together because they are kind of interconnected and dependent on each other. This is the Internet of Things, which I have already explained. This is one of the example of Internet of Things. It's a monorail monitoring system which is using Azure IoT in order to process the data that is coming up from our monorail system. And the same thing, it's going through IoT hub, it's processing data, it's streaming it through analytics, storing the data in Cosmos DB, and then it is displaying the data through app services. Modernization of microservices, again, as I have already mentioned, we are moving more into the modernization of applications because of the lack of support system of the legacy softwares or applications or capabilities. We need to have our application more modernized. So most of the industries right now, which has been built almost like 15, 20 years back, they have their applications that doesn't follow any patterns, no practices, they have many issues, they are not optimized, they are very much performance hit. Those applications, they are trying to move towards more microservice level architectures, and the industry is in demand of people who have extensive knowledge on microservices and how they work. All right, so that's all from my side. I hope this session gave you kind of an idea, an overview of what the technology landscape looks like, what we are dealing with, and how we are going to what's coming up, right? What's going to happen. And not only this technology is there will be again a change of technology. There will be new technology which is going to come up in maybe within next 1-2 years. So it's going to change. It's an evolving stage, and every industry, every market, every IT departments, IT companies, they are in lookout of those candidates who have good amount of knowledge, at least have a minimum amount of knowledge about these technologies and can learn and implement them in their solutions. Okay, so with that, thank you, and I hope this session was really useful. Thank you for listening. Happy learning.